Hello everyone, welcome to BYJU'S Exam Prep IAS. Welcome to this session on Prelims 2024 analysis of all the questions that came from the areas of science and technology. So let's have a discussion on all these questions. So the first question that we have here is question number 67, and mind you, we are taking set D, and in set D these are the question numbers. So question number 27 says, consider the following statements: battery storage, biomass generators, fuel cells, rooftop solar photovoltaic units. How many of the above are considered distributed energy resources? So these are the options that have been given in front of you, and you have been asked only one of them or two of them, three of them or four of them. This is what exactly they have asked you. Now, the very first thing is to understand what do we mean by distributed energy resources, right? So when it comes to distributed energy resources, all these four options that have been given in front of you, all these are correct. All these are considered as distributed energy resources. Now, what are these? Distributed energy resources, they refer to electricity producing resources of, you can say, controllable loads that are connected to a local distribution system, or they are connected to a host facility within a local distributed system, right? So just understand this, that we are talking about the resources or the loads that are connected to a local distributed system. Now, in this context, when we look at all these four options given in front of you, you have to understand that these all have to be decentralized, they have to be modular, they have to be more flexible technologies that are located close to the load that they are serving. So that's why they can reduce the load on the transmission and the distribution systems, and they can contribute to environmental and energy resilience as well. So when we look at all these categories, when it comes to battery storage, they can store excess energy which are generated during the low demand periods, and they can supply it during the peak demand periods, right? So battery, we know that we locally can store it, so that's why battery storage is correct. The second one is biomass generators. They basically can produce electricity by converting the organic material into power. So that's why they also can be used here as distributed energy resources. Then after that we have fuel cells. Now fuel cells, they would convert the chemical energy from the fuels into electricity through a chemical reaction, and they also can do that locally. They are similar to what we are talking about in battery storage. And then lastly we have rooftop solar photovoltaic units. So in this case also, they generate electricity directly from sunlight, which are using the solar panels installed on the roofs of the building. So they also can be considered as distributed energy resources. So recently, you know that we have seen in the context of the new Surya Ghar Yojana, where the government of India has come out with rooftop solar photovoltaic units. So all these four given here, all of them can be considered as distributed energy resources because they are very close to the load, and that's why they can be considered the same. Moving on to question number 79. Question number 79 says, consider the following plants: groundnut, horse gram, soybean. How many of the above they belong to the pea family? So this is what the question is. Now again, they have asked it in the similar fashion of what we have seen in the last couple of years: only one, only two, all the three, or none of the above. Now in this context, when we look at all these, just understand that we are basically talking about these three plants, and groundnut, horse gram and soybean all belong to something what we call as the Fabaceae family. Alright, so they all belong to the Fabaceae family, which are commonly, you know them commonly as legumes, right? You might have heard of legumes. So the legumes or the pea family, or specific to these, are the bean families. So all these can be considered as the Fabaceae family, right? They are all considered as the Fabaceae family. So that's why they all can be considered. So this family plants, they basically are very often, they are seen to be nitrogen fixing plants, or that's why they have the nitrogen fixing bacteria in their root nodules, and at the same time they become very valuable for the soil health and agriculture as well. So that's why all these three, groundnut, horse gram and soya bean, they can be considered to be belonging to the pea family. So the correct answer, that's why, will be all the three. Alright, so question number 79, the answer will be C, all the three. Moving on, question number 86. Consider the following materials: agricultural residues, corn grain, wastewater treatment sludge, wood mill waste. Which of the above can be used as feedstock for producing sustainable aviation fuel? Right? So when we say feedstock, in the class also we had discussed this, that we are basically meaning the raw material that can be used for producing sustainable aviation fuel. Now, sustainable aviation fuel is, you can say in a manner, is kind of biofuel which is used to power the aircraft, which have similar properties to conventional jet fuel but with smaller carbon footprint. Alright, so that's why they are sustainable. And depending on the feedstock and the technologies that are used to produce it, these sustainable aviation fuel, they can reduce the life cycle of the greenhouse gas emissions, and that's why they become very crucial, or they are very, you can say, much better as compared to the conventional jet fuel that we are using. So when we look at some of the emerging SAF pathways, they very often we see that they have even negative greenhouse gas footprint. So that's why they have very low carbon intensity, and they become very important solution for reducing the aviation greenhouse gas emissions. And we very often talk about the fact that when it comes to the aviation industry, the carbon footprint of the aviation industry is severely high. Right? So that's why we see that in this context, we see that there are all these new biofuel based solutions or sustainable fuel based solutions which have started coming in. Now, in this context, when we look at all these options given, corn grain, agricultural residues, they actually can be used. Corn grain can be used, wastewater treatment sludge can be used, and wood mill waste can also be used. At the same time, you can also use algae. We can also use algae if we want. We can use the oil seeds as well. We can use oil seeds as well. It has been in the news that even different types of oil seeds are being used by many of the aircrafts. In this context, it becomes crucial to understand that this is possible. For example, aircrafts like SpiceJet aircraft, etc., they already have begun doing all this, and they had declared this publicly as well a few years back. So that's why they can be used. Similarly, other oils and fats, greases, etc., they also can be used. At the same time, forestry residues, they also can be used. So there are a lot of these feedstock. Just imagine that every feedstock that we can create, we can use for creating biofuels, they can be used for sustainable aviation fuel as well. Similarly, we see that manures can be used, treatment sludge, as we discussed here, can be used. Dedicated energy crops are there. We had discussed that in the classroom also. They also can be used. So all of them can be used. So that's why the correct answer here will be 1, 2, 3, and 4. All of these can be used. Moving on to the next question. Which of the following words or phrases is the most appropriately used to denote an interoperable network of 3D virtual worlds that can be accessed simultaneously by millions of users who can exert property rights over the virtual items? So in this context, there are 4 options given: big data analytics, cryptography, metaverse, and virtual matrix. Now in this context, the correct answer here will be metaverse, because metaverse refers to a collective virtual shared space which have been created by convergence of virtually enhanced physical reality and physically persistent virtual spaces. So that's why all the, you can say, all the virtual worlds, augmented reality, the internet, all these things can actually fit into it. So that's why the description that have been given, the interoperable network of 3D virtual worlds that can be accessed simultaneously by millions of users who can exert property rights over the virtual items, this perfectly sets into what metaverse is. So that's why virtual reality, augmented reality, all these things actually can come into metaverse. So that's why the correct answer will be C. Moving on to the next question, question number 91. With reference to the radioisotope thermoelectric generators, consider the following statements. First, RTGs are miniature fission reactors. RTGs are used for powering the onboard systems of aircrafts. RTGs can be plutonium-238, which is a byproduct of weapons development. So these are the three statements given in front of you. Now, in this context, when we look at all these statements given here, we had discussed this, if you remember, as the applications of nuclear technology in the classroom. We had discussed about this, that the spacecraft, especially if you remember, we had discussed that ISRO has been creating RTGs, has been working on RTGs, and this might help in the deep space missions. It might help in the deep space missions if ISRO plans it in the future. Right? So in this context, we had discussed that they will be used for powering the onboard systems of aircrafts, and we are making the use of plutonium-238. Now looking at, so that's why statement 2 and 3, that's fine. Let's look at statement number 1. So statement number 1 says that they are miniature fission reactors. Now this statement is not correct, because RTGs are not fission reactors. Instead, they can be considered as devices that convert the heat that has been released by the decay of radioactive isotope into electricity with the help of a certain phenomena, a kind of a thermoelectric effect. That's why they are called as thermoelectric generators, because they are like generators. They are not like fission reactors, because in fission reactors, what happens? In the fission reactors, they involve the splitting of the nuclei, correct? Splitting of the nuclei, which is not how RTGs would operate. They would simply use the heat that is being generated by the radioactivity of plutonium-238 and use that heat to convert into electricity. So that's why we should not call this as miniature fission reactors. So that's why 2 and 3 are correct, and 1 should not be considered as correct. So that's why RTGs basically, you can say that they are used in powering of the spacecrafts. NASA and other European Space Agency, etc., they have it. ISRO now also has developed it, and they have been used in several space missions, including even the Voyager mission that has been in the news, or the Curiosity mission that has gone to the Mars. All these, they already have used the RTGs, and they particularly become very important in the areas where solar power is unreliable. That's why we are talking about the deep space missions, where we are going away from the solar system. So in these cases, they can be utilized. So that's why statement number 2 perfectly fine. Statement number 3 is also correct, because when it comes to plutonium-238, it is primarily synthesized for the purpose of fueling the RTGs. It is actually a byproduct of the process of producing plutonium-239, which is used in nuclear weapons. And that's why we have to understand that when it comes to plutonium-238, it is highly suitable for RTGs because of high power density and having a very high, very long half-life of almost 90 years. So that's why we see that it can provide steady power supply for decades. For example, missions like the Voyager mission and all these, we know that they have been functional for decades. They have been functional for 20 to 30 years. So that's why in that context, RTGs are very, very important. So that's why question number 91 answer should be B, that is 2 and 3 only. Moving on, question number 92. Consider the following statements. Statement number 1. Giant stars live much longer than dwarf stars. Statement number 2. Compared to the dwarf stars, giant stars have a greater rate of nuclear reactions. And the question has asked which of the following is correct in respect of the above statements. So they have asked whether both the statements are correct, and statement number 2 explains statement number 1. Second is statement 1 and 2 are correct, but 2 does not explain statement number 1. Then C says statement 1 is correct, but 2 is incorrect. And D says statement 1 is incorrect, but statement 2 is correct. So these are the 4 statements or 4 options given in front of you. Now, when it comes to these reactions, or let's say these stars, giant stars and dwarf stars, giant stars actually have a much shorter lifespan as compared to the dwarf stars, because when it comes to the giant stars, they actually burn through their nuclear fuel at a much faster rate due to the large amount of mass that they have and high pressure and temperature that builds into them. And this is what actually accelerates the nuclear fusion reactions. So if you remember, in the classroom when we talked about the life cycle of a star, we discussed about the fact that when a star dies, it first converts into a red giant or a red supergiant, which becomes highly unstable, and in case of red supergiant especially, an explosion happens at the center because of its instability. So towards the death of the star, it becomes a giant star, and then explosions can happen there. Or in terms of an average star, we discussed that they would convert into a red giant, and then after that, we see that they would convert into a dwarf star, that is a white dwarf in that case, and then they would exist as a white dwarf for a long time. So compared to dwarf stars, giant stars have a greater rate of nuclear reaction. Giant stars live much longer than dwarf stars is wrong, because they live much shorter compared to the dwarf stars. So that's why statement 1 is wrong. So this is gone anyway, right? Because and even this is also gone, because statement number 1 is not correct. So C is also gone. So we are anyway left with only statement the option number D. So second statement basically says that compared to dwarf stars, giant stars have a greater rate of nuclear reactions. Now this is correct. When it comes to the giant stars, they undergo rapid nuclear fusion, which produces a greater amount of energy output compared to the most of the steady and slow fusion processes that we see in the average stars and dwarf stars. So that's why statement 2 is correct. The intense amount of nuclear activity in the giant stars is actually due to the massive cores that they have, which supports very high rate of fusion, and thus also leading to a shorter lifespan. So if let's say they had given statement 1 as shorter, then in that case statement 1 would have been correct, 2 would have been correct, and 2 would have been the correct explanation for statement 1. But that's not the case here, so correct answer will be D. Moving on to question number 93. Which of the following is synthesized in the human body that dilates blood vessels and increases blood flow? So all these nitrogen oxides have been given in your options. The correct answer will be nitric oxide. Nitric oxide is a gas which is naturally produced in some of the endothelial cells in the lining of the blood vessels. All right. So in the what we have in the endothelial cells, they would basically will be able to, linings of the endothelial cells in the blood vessels, this is where we have nitric oxide being produced, and it serves as, you can say, a signaling molecule that instructs the smooth muscles which are surrounding the blood vessels to relax, and that's why they dilate the vessels by doing this. So this is a process that we see which increases the blood flow and it decreases the blood pressure, and this is a process which is also called as vasodilation. This is a process that is called as vasodilation. Alright, so this basically is a process which would increase the blood flow and decrease the blood pressure. And unlike some of the other options that have been given here, like nitrous oxide, nitrogen dioxide, and nitrogen pentoxide, nitric oxide is specifically synthesized in the body for this very purpose, and that's why it plays a very crucial role in also maintaining the cardiovascular health of the human body as well. So that's why the correct answer here will be A. Moving on to question number 94. Consider the following activities: identification of narcotics on passengers at airports or in aircraft, monitoring of precipitation, and tracking of migration of animals. In how many of the above activities can radars be used? Alright, how many of the above radars can be used is what you have been asked. So in the first one, the first statement that we have is in the context of identification of narcotics on passengers on airports or in aircraft. Now, the traditional radar systems are not typically used for detecting narcotics on passengers. Instead, what we see is that there are other scanning technologies and imaging technologies that are used. For example, we use X-ray machines, right? We make the use of X-ray machines. At the same time, we also have other technologies like the millimeter wave scanners. So we also have the millimeter wave scanners. They can be used, and then there are some of the chemical detectors also sometimes which are used. So these are the technologies that can identify the objects which are hidden under even clothing or inside the baggage, but they do not really use radar technology in the detection of the distant objects through radio waves. So that's why in this context I would say that this is not correct. Then second is monitoring of the precipitation. Now meteorological radars are there and they are extensively used to detect and also to track the precipitation. These kind of systems, they would emit the radio waves that would bounce off the precipitation particles, and they would provide the data on the location, on the movement, and also on the intensity of the precipitation like rain or snow, etc. So that's why this can be done. Third is tracking of migration of animals. Now there are biological radars, also called as bioradars, and they can monitor the movement of large groups of animals, specifically in the context of birds. And these radars, they are capable of detecting the biomass and the movement of the patterns of the animal groups, and that's why they become very, very vital in the study of the ecological and the conservational practices in these migratory birds. So that's why this third statement is also correct, and that's why the correct answer here should be 2 and 3. That's why only 2 of these statements have to be considered as correct. Let's move on to question number 95. Consider the following aircraft: Rafale, MiG-29, Tejas Mark 1. How many of the above are considered as 5th generation aircraft? Now, in this context, when we are looking at these 3 aircrafts here, the generations, basically when we talk about the generations of aircraft, every time we make certain improvements in the aircraft technology, we say that it's a new generation of aircraft. Now, in this context, when we talk about 5th generation aircraft, this is where we see that very extensive use of software and computing is done. So those kind of aircrafts, they are called as 5th generation aircraft. Now Rafale, when it comes to Rafale, this we know that it is a French 2-engine multi-role fighter aircraft, and which have been bought by India from France. This is classified as a 4.5 generation aircraft, not a 5th generation aircraft. There are advanced avionics here, stealth technology has been given here, but it does not really meet all the things that we need, all the criteria that we need for it to be classified as a 5th generation aircraft. For example, enhanced stealth features and integrated avionics using the softwares. So that's not there. So that's why this cannot be considered. Then after that we have MiG-29. Now MiG-29 was developed by Soviet Union, and this is a 4th generation aircraft. This is a 4th generation aircraft. And at the same time we have Tejas Mark 1. So Tejas Mark 1, we know that it is an Indian lightweight combat aircraft, and primarily this can also be considered as the 4th generation aircraft. So that's why, again, because there is lack of comprehensive stealth or advanced radar systems or sensor integration which are typical in the 5th generation, that's why this also can't be considered as the 5th generation. So none of the above can be considered as the 5th generation aircraft. Moving on, question number 96. Which of the following are hydrogels used? First, controlled drug delivery in patients, mobile air conditioning systems, preparation of industrial lubricants. So these are the 3 statements given. Select the correct answer using the code given below. So these are the 4 options in front of you. Now, in this context, if we look at these 3, first is controlled drug delivery in patients. Now hydrogels, basically they are 3-dimensional polymer networks that can actually hold large amounts of water while maintaining their structure. Alright, so just understand that they are three-dimensional polymers. They can be considered as three-dimensional polymers or polymer networks that can hold large amount of water, right? They can large amount of water while maintaining their structure, while maintaining their structure. So this actually makes them very ideal for biomedical applications, particularly when it comes to controlled drug delivery in the patients. And that's why they can be engineered to also respond to specific stimuli as well, to the pH level, temperature, enzymes, etc. And that's why they can release the drugs in a very controlled manner over time. So this targeted delivery also helps in reducing the side effects and also improve the efficacy of the medicines that we are using. Second is mobile air conditioning systems. Now hydrogels actually can absorb significant amount of water and release it through evaporation, and which actually can create a kind of cooling effect. And this property is something that is harnessed in various different types of cooling applications, including the mobile air conditioning systems. Now the hydrogel basically can absorb water, and at the same time the water would also evaporate. So that's why it would absorb the heat from the surroundings and it would provide a cooling effect. So that's why mobile air conditioning system, it can definitely be used. Then after that we have preparation of industrial lubricants. Now in industrial applications, hydrogels actually can be used as lubricants also, because of their ability to reduce the friction or reduce the wear and tear. They can provide a very smooth, consistent lubricating layer that can actually be operated, you can say, operate very effectively under very wide range of temperature and pressure conditions. So that's why it makes them very valuable in various different mechanical systems where we want to reduce the friction and want to reduce the wear and tear. So that's why in all these three cases we can make the use of hydrogels. So that's the correct answer will be D. Moving on, next question, question number 97. Which of the following is the exhaust pipe emission from fuel cell electric vehicles powered by hydrogen? Hydrogen peroxide, hydronium, oxygen, or water vapor? Now, in the context of when we are talking about fuel cell electric vehicles, now understand that first and foremost we are talking about fuel cells. Now these fuel cell electric vehicles, they are using hydrogen as fuel, and inside the fuel cell, hydrogen gas would react with oxygen from the air to produce electricity, water and heat, right? So this basically is a simple reaction where we are talking about a reaction like 2H2 plus O2 producing 2H2O. So this is, you can say, a basic reaction is, right? Now in this reaction, this generates electricity to power the vehicle's electric motor, and at the same time the byproduct here would be water in the form of water vapor. And unlike the traditional internal combustion engine vehicles that emit various different types of pollutants, here what we see is that they only emit water vapor, and that's why it makes them a much cleaner alternative. So that's why this is basically what we see happening. And anyway, wherever you have fuel cell, you know that byproduct of a fuel cell is always water. So you can derive your hint from there as well to get to the answer, that is water vapor. Moving on, question number 98. Recently, the term pumped storage hydropower is actually and appropriately discussed in the context of which of the following? Irrigation of terraced crop fields, lift irrigation of cereal crops, long duration energy storage, and rainwater harvesting systems. Now when it comes to the pumped storage hydropower, this is a typical hydroelectricity energy storage which is used for balancing the grid. It is the most widespread type of energy storage which is used on a large scale. And the basic principle here, is something that involves, you can say, two water reservoirs at different elevations. And during the period of low electricity demand, the excess energy is used to pump water from the lower reservoir to the upper reservoir. And during the periods of high electricity demand, the stored water is released back down into the lower reservoir through turbines, and this is something that would generate the electricity. And this method, that's why, is very highly effective for storing and managing the energy, and also helps in maintaining of the grid stability as well. So that's why it is something which can store large amounts of energy for extended period of time, and that's why it makes it very ideal for long duration energy storage. So that's why the correct answer here would be C. Moving on to the last question in science and technology. Membrane bioreactors are often discussed in the context of assisted reproductive technologies, drug delivery nanotechnologies, vaccine production technologies, or wastewater treatment technologies. Now, when it comes to the membrane bioreactors, they combine the biological treatment with the membrane filtration to treat wastewater. So that's why in a kind of a membrane bioreactor system, the biological degradation of organic matter is performed with the help of microorganisms. All right, and these microorganisms, then after that what we see is that the treated water is then filtered through the help of certain membranes. All right, certain membranes to remove the suspended solids or the pathogens which would be which would be present here. So for example, there are ultrafiltration techniques, UF, ultraviolet filtration techniques, or ultrafiltration techniques. In your RO filters, they talk about that it has RO plus UV plus UF and all these things. So that UF, that is ultrafiltration, is where we are removing these solid particles, all right, smaller solid particles or even pathogens. So these are very highly effective for wastewater treatment due to all these different advantages that they have. We see that they, for example, they produce very high quality effluents. They can be very safely discharged into the sensitive environments as well. And at the same time, they can be used for irrigation or industrial purposes. Then at the same time, they require very less space as compared to the conventional wastewater treatment systems, because the membrane filtration, it actually replaces the secondary clarifiers, etc. So that's why we see that the process also here is much improved process. We see that they improve the reliability and the stability of the treatment processes. So because of all these things, we see that these membrane bioreactors, they are preferred choice for advanced wastewater treatment facilities, and especially in the areas which have very stringent discharge regulations or have very limited space. So that's why they are used in wastewater treatment technologies. Alright, so question number 99, the answer will be D. So these were the questions that came from the perspective of science and technology. I hope that these explanations help you in understanding of how exactly the questions have been asked and what should be the correct answer. So with this, we come to the end of the session. Thank you very much for being here.